My name is Ian Strachan, a journalist turned science communicator.
And I'm Sarah Perkins-Kirkpatrick, a Professor of Climate Science at the Australian National University in Canberra. We're members of the Australian Research Council Centre of Excellence for the Weather of the 21st Century.
And this is Totally Cooked, the climate and weather podcast.
In this episode, we're going to explain how climate science works. How can we be sure that global warming is caused by humans? And what can we do about it?
We're also going to meet some of the most important scientists and researchers in the history of climate change, the people who first understood the problem and then started sounding the alarm bell. Sarah,
Yo!
that's you. I trust climate scientists when you tell us that the world is getting warmer.
And that warms my heart.
Yeah, I trust you so much. And I believe that that's being caused by human activity. So I'm in the good books, right?
Yeah.
But how do we know that the world is getting warmer? And how can we be sure that it's human activity that's doing it?
We've actually known for like hundreds of years how the atmosphere keeps the earth warm and the role of certain gases in the atmosphere that does this. It's not just something that's popped up in the last couple of decades. We've literally known about the science itself for hundreds of years.
So thinking about the proofs, you've said that we've understood the greenhouse effect. What is the evidence that the world is getting warmer? How do we know that? Measuring
the temperature of the earth at the surface, so at ground level pretty much. Since the Industrial Revolution, temperature's been going up. Another way of measuring how the earth is changing is looking at the ocean heat content, because most of the world is ocean. It goes really deep and it takes a lot more energy to heat up water than it does land. And that increase is a much more steady increase than what we see in the atmosphere. So when we're talking about global temperature, peaks and troughs over some years, but overall it is increasing. But if you look at ocean heat content, it's a pretty linear increase. It's, every year is almost warmer than the next.
What we want to talk about today is who the first people were to raise the alarm, as it were, about what that could do to the planet. And two of the first people I have in mind actually are Joseph Fourier and Claude Pouillet. Are they on your radar in any way, Sarah? Have you ever heard about them during your studies and career?
So I'll be honest, I haven't heard of the second guy. I haven't heard of Claude.
Mm-hmm.
But I did a bit of research. I'm like, that's where that number came from. And then with Joseph Fourier, there's something in mathematics called Fourier transforms. So I'm like, I didn't realize he did something in climate as well. But basically Joseph was the first one to propose that the atmosphere had a role in keeping the planet warm.
Mm.
So there was something about it, probably something about the gases in there that helped keep the planet warm. And if we didn't have an atmosphere, the planet would be a lot cooler.
He calculated that given the balance of incoming energy from the sun and outgoing infrared energy, the surface of the temperature of the earth should be much lower.
Yeah, he crunched a few numbers and realized there was a bit of an imbalance there. So something must have been happening in our atmosphere to kind of hold that radiation in place for a bit longer to warm up the atmosphere.
In some respects, it's a bit like how we know that dark matter something must exist. Otherwise, Einstein's equations about the weight and gravity and things in the universe don't add up. Like there's a big missing thing there going on. And maybe it was a bit like that, like
yes,
there's something else happening here that he didn't understand.
Yeah, exactly. Yeah. But whether it was he didn't have the time or the technology to understand that further, perhaps if he was alive 200 years later, he would have worked it out in much more detail. But yeah, there was something going on. Something didn't add up. And his proposition was there's something in the atmosphere that means that we are warmer than what we really should be.
And his mate Claude, Pouillet, Pouillet.
I'm not even going to try.
He thought that it might be water vapor and CO2 keeping the heat in.
I think that was beyond his time, to be honest, because I'm sure we'll talk about them in a minute, but there was other scientists a bit later than him that demonstrated certain things, but he could only hypothesize. He couldn't prove
exactly.
it.
He didn't have experimental proof. And there'll be a few people we'll come across today who were doing these kind of back of the envelope analog calculations so long ago, when they're like dipping quills in ink pots,
pretty much.
And then like preempting supercomputing calculations.
I can only imagine, right, like whether that was in Joe's and Claude's time or a little bit later on, like to say, look, we've measured something, and for the scientific community to go either you're nuts or, we're accepting this. It's a huge thing to discover these things. And a lot of them it was, you're a bit nuts, we're not going to believe you, because it was, so much of a game changer.
And in a world where, the Enlightenment marks the departure from this, but the church was the authority that had all the knowledge. You know, scripture was the answer to everything. And so, and these
will be fine.
And most of these people were still like obviously very religious as well. And to try to kind of navigate that weird tension between belief in scripture and the mounting kind of scientific evidence contradicting some of it.
What was it back then, right? Like, God does everything. God created the earth in 7 days. You know, let's all thank him for all the sunlight we receive. And someone's like, oh, I've measured the number. Or, oh, it's actually the atmosphere that's changing our climate. It's got nothing to do with God.
It must have been tricky to speak up about this kind of thing. Having checked in on those two very, very early pioneers of this science, we might get to some people who you're a bit more familiar with now. I want to talk about Eunice Foote and John Tyndall.
Yes.
Can you tell us a bit about what you know about Eunice Foote?
Yeah, poor old Eunice, hey. She was an amateur scientist, largely because she was a woman. And so she, very smart woman, descendant of Isaac Newton.
Have we verified that?
I swear I have verified that.
You swear you verified it?
Yes, it says the person who lost her recording equipment this morning.
Let's have a look. I'm Googling.
It's Eunice Newton Foote. Like,
distant relative. It says on Wikipedia, which, you know, is peer reviewed.
What did I say yesterday? She was his daughter, and I realised she was like 100 years too late.
At least 200, really.
Oh, 200. Oh, yeah. Oh, she was born 1819. Wasn't he in the 1700s?
Yeah, well, let's have a look. Isaac Newton. Isaac Newton died in 1727. So, yeah, 100.
Anyway, Eunice was an amateur scientist, and what she did, she didn't have a lab of her own. She did this in a backyard. She filled different cylinders with different gases to see how they. What am I doing? Sorry.
No, when you said she didn't have a lab of her own, I've got a literary digression here. You know, like Virginia Woolf wrote A Room of One's Own, which is about it's about a woman having the space to have a creative voice. Like,
oh, okay. Yeah.
It's a feminist literature and science crossover that I think will be lost on everyone except
it's not
me.
Intentional because I've not read that book, but very
You
smart.
You haven't?
No.
Okay.
Just think of me a little bit less now, right? Anyway, I digress. Poor Eunice. So, yeah, she did this experiment where she filled up all these cylinders with gas, different types of gas, and left them in the sunlight. And one of those gases was carbon dioxide. And she noticed that the temperature in the cylinder with carbon dioxide was much, much, much hotter than the ambient temperature. So she kind of identified carbon dioxide as a greenhouse gas, so as a gas that has heat trapping properties. But she put it down to sunlight. She put it down from the incoming radiation from the sun, not this outgoing long wave radiation or the infrared radiation that rebounds off the earth after we get sunlight coming in. So she was, another step. However, this why I keep saying poor Eunice is no one knew about her work. Not even John Tyndall, who is the next step in the chain, knew about her work. And she made this discovery only a few years earlier, before the father or grandfather of climate science or climate change science came up with his experiments. So they didn't really know each other. And he, was a professional scientist. And he showed in labs that the heat trapping properties of greenhouse gases such as carbon dioxide and water vapor. So he was able to show, they trap energy, they make things hotter, but it's not from the sunlight, it's from the infrared radiation. And that's where I can't even say that word,
spectroscopy.
Thank you. It sounds like some sort of procedure that the doctor does on you.
What's the gap fee?
Pardon?
What's the gap fee for spectroscopy? How much do I owe the anaesthetist?
It sounds like one of those women health checks that you have to do every 5 years. But he did that in a lab. He showed that carbon dioxide, without getting too in depth, but carbon dioxide absorbed certain bands of infrared radiation.
I was going to interject here actually, which is that we're here to set the record straight and to take away ammunition from the conspiracy theorists and the climate deniers, but I do want to like stir the pot a little bit, right? Which is that you were saying that Tyndall didn't know about Foote and she just was a bit kind of like a bit unlucky amateur scientist, but she did publish her findings in a scientific journal. She
under
was
a male name.
Yes. And they were presented by someone else at a conference.
Yes.
But, she was the first woman to be published in the field of physics in the US, the first American woman other than an astronomer. And that was in 1856. And the next one wasn't until 1889. And
that is true. It was relatively unknown, her role in climate science, until recent times. These the progressions that we used to think about in terms of our understanding of greenhouse gases and how they work were never really put down to her, or her role wasn't understood and acknowledged until very recently.
And meanwhile, Tyndall was working at the Royal Institution in London, which was and is still quite a prestigious organization that's done a lot of work in advancing physics and chemistry, and which has always had a role in what we're doing now, like science communication. So they used to have public lectures. I actually went there a couple of years ago to the lecture theatre, where they used to do these kind of experimental proofs and demonstrations.
Right.
And Tyndall, was doing that. He was showing people in person his experiments and explaining them. But what if, and this is just speculation, there's no proof of this, what if he did know about Foote's work? What if he read that paper? Because there was a lot of exchange between American and British academics in the 19th century. Some people have speculated that he pinched it. What do you think?
I don't know. I haven't really thought about it, to be honest. I think now that wouldn't fly, right? 3 years in between these discoveries, all of our science is publicly available, or at least available to the scientists in journal articles, blah, blah, blah. It'd be pretty obvious that it was stolen and someone else was, shafted for their own research. Back then, it's possible that he simply didn't know, right? Because she did publish, but it wasn't under her name. And if she did publish this results, she did, right? It was under a male name. There was no excuse for him not to know, right? He wouldn't have known it was by a woman, so that sort of bias couldn't have come into it. Things took a while to travel. I mean, I don't know. I really don't know how journal publications worked back then. Were they sent internationally? Was it all done in country? I'm really not sure. But I think it's much more feasible that he didn't know back in the 1800s relative to now. Okay, so.
And I'm just enjoying being able to safely stir the pot about people who are long since deceased and who can't sue us for libel.
That's right. And you're watching me squirm as like teetering on the edge of male sympathizer in a feminist, described as a feminist.
Your words, your words. So regardless of who came up, regardless of how it went down and whether it was, coincidental or more devious, they both essentially identified and started to experimentally prove the greenhouse effect for all intents and purposes.
Yes. Yep. Yeah. So they basically, both of them said, we've got greenhouse gases. They didn't use that term. That term didn't exist back then. That's a more modern term. But they noticed heat trapping properties of these gases.
Yep.
And Tyndall, of course he could go a few steps further and demonstrate this with that funny named machine that I'm not going to mention because I'm going to look like a fool again. But could, send that infrared radiation through the gases to say, yep, it traps the heat or the energy that turns into heat.
Do you mean a spectrometer?
That's the one, the funky machine with like that long tube and things either side. But he looked at water vapor in a bit more detail as well. And he actually worked out that water vapor is also a greenhouse gas, right? It also has heat trapping properties. But the thing is with water vapor is it's very transient. Carbon dioxide is not.
Okay. So we've got these two people in the US and in Britain, roughly the same time, starting to experimentally demonstrate this.
Yeah.
And moving away from the UK and the US, can you think who we're going to talk about next? Who is the person who takes this on a level?
The guy with the funky name.
Svante. Svante.
That sounds like Dante, but it's completely the wrong country.
Well, Svante's Inferno. It's another literature reference.
Oh God, I've got to read.
Dante's Inferno?
Just remember Dante's Peak, that terrible movie about the volcano. But anyway. No.
You say terrible. I say very entertaining.
Really? Watching people boil in pits of lava?
Yeah, that's very entertaining.
The ash chasing them down the hill. That wouldn't happen.
Well, actually, Inferno is the poem by Dante Ilagieri, but we're talking about Svante.
Sorry, yes, Svante Arrhenius. I'm probably said that wrong too. But
I don't know how to, I mean, we should probably have looked up the pronunciation. I'd say Arrhenius. There is an H there.
There is an H. Svante
Arrhenius,
well,
Arrhenius.
he's Nordic, right? So I've got
Swedish.
no idea.
Swedish,
that's right. Anyway, Svante came up with what we now call the climate sensitivity. He came up with I wouldn't even say the equation, but hypothesized what the sensitivity of the climate is to increasing carbon dioxide. So he basically said that if we double the amount of carbon dioxide in the atmosphere, then we can expect, an increase of roughly 3 to 4 degrees Celsius of global temperature. I will actually mention, though, so I'm just going to go back to dear old Eunice. She actually hypothesized that if we put more carbon dioxide in the atmosphere, in the Earth's atmosphere, that global temperature could go up. She was the first one to actually suggest that. Yes, she measured carbon dioxide and incorrectly got it down to sunlight and heating up. But she thought, if we put more carbon dioxide in the atmosphere, then potentially the Earth's temperature could warm.
And then Svante ran the numbers. Yes,
Svante ran the numbers. I don't know if he knew about Eunice or not. But he ran the numbers and he came up with this, what we call the climate sensitivity. And that term, climate sensitivity, is what is regularly used today. And a lot of climate scientists actually dedicate their time to understanding what is the true sensitivity of the Earth's system to a doubling of CO2 in the atmosphere.
It's a good job they're not running the sensitivity on me. Otherwise, it would be alarming results, really sensitive.
Just a little bit of carbon.
Yeah, a little bit of carbon will set me over the edge, make me really upset.
Just microdose you with carbon.
And ironically, the reason he was doing this was he was trying to explain the ice ages.
Yes, yeah. He was basically like, it's fine, we'll be fine. we don't need ice. Let's have an increase.
He actually wrote a book about what he thought of his findings, and I'm going to send you a little quote, Sarah.
Okay.
For you to read out to us.
Know that he read the book. That he wrote a book. By the influence of the increasing percentage of carbonic acid in the atmosphere, that's carbon dioxide, we may hope to enjoy ages with more equitable and better climates far out, especially as regards to the cooler regions of the Earth, ages when the Earth will bring forth much more abundant crops, if I don't laugh, I'll cry, than at present for the benefit of rapidly propagating mankind. Oh, that hurts.
So it's all good.
It's fine. He thought it was amazing. And he actually thought that it would take us 500 years before we doubled the amount of carbon dioxide in the atmosphere due to human activity.
He didn't bet on the automobile industry or airline travel.
No, just capitalism in general, really.
Capitalism, yeah.
We haven't quite doubled it relative to Industrial Revolution times, but we're not far from it. We're currently at 427, I think, and it will have to be around about the 560 for it to be considered doubled, but we'll get there soon enough.
In some respects, he's not wrong in that, the climate in Scotland or Iceland or Sweden is going to be pretty good.
I'm not taking the bait there. I'm not no, I can't go there.
The climate everywhere else is going to be very bad.
The tropics are already pretty, I wouldn't say the word that came to mind, but they're already teetering on the edge. And I get again, back then, let's give them, a bit of credit, cooped up in cold Sweden and cold Europe. They didn't completely understand other climates so much, but...
I was talking to someone about this yesterday. They were also just only coming out of the Little Ice Age.
That's right.
Which for anyone who doesn't know, between around, early modern periods, so 1500s, 1600s, 1700s, the world was a lot colder than it was before or afterwards because of a few different things, including a couple of volcanoes going off and adding a lot of ash into the atmosphere. But if you think about Christmas cards and those Christmas scenes that we have in our heads from Northern European culture, those aren't exaggerations. Rivers used to freeze over a lot more. We used to have a lot more snow there than we do now. And so someone coming out of hundreds of years of that being normal, it's not surprising that he thought, maybe this isn't too bad.
Winter and more winter, particularly with the volcanoes going off, because they just basically stop the sunlight coming in the first place. And if you can't get the sunlight coming in, then the Earth can't rebound infrared radiation. So there's just no heat. And look, I kind of get that. Again, coming from cooler climates, coming off the back of ice ages, mini and long ones as well. I can understand naively how they thought it was a good thing. And not like, they couldn't have predicted that everyone would just, would have so many cars and even flying, right? Like that's a huge emitter of greenhouse gases. That was not a thing back in Arrhenius's time.
It might sound stupid to ask it, but why is it not a good thing?
Well, okay, so I can give you my scientific viewpoint here.
Yeah, that's I'm not being facetious or annoying. Like genuinely, what are the negative impacts that we're already are experiencing and are going to experience from having more carbonic acid in the atmosphere?
Yes, carbonic acid. It just sounds like it's just going to rain acid all the time with that term, but it is what it is, right? The issue with having more greenhouse gases in the atmosphere is it heats up the climate, but particularly for carbon dioxide, it stays in the atmosphere. It's not like water vapor, which is transient, and even like methane, which is far more potent than carbon dioxide, but there's much, 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 much less of it in the atmosphere currently, and also it doesn't last as long in the atmosphere. So we emit it. It stays there for hundreds of years and it keeps things permanently elevated, the temperature permanently elevated. And then it can start chains of reactions, of events and things that once they run away, once we reach that tipping point, we can't reverse. So, if everything's hotter, the ice caps melt, right? And sea ice melts. Now, what sea ice usually does is reflect that shortwave radiation from the sun straight out back into the atmosphere, so it doesn't heat up that area. But when it melts into ocean, it's much darker, and that actually absorbs that incoming solar radiation, which then re-emits as long-wave radiation, which heats up the Earth more. This sort of chain of reaction is just not just a simple, I'll be a little bit warmer in my area.
More moisture in the atmosphere,
more moisture,
stronger storms.
For every degree warming, the atmosphere can hold 7% more moisture. It's a whole bag of problems. It's a whole can of worms that has been opened. Like, it'll be fine. We'll just put a bit of carbon in the atmosphere and it'll heat it up and we'll all be fine and our crops will survive, and that's great. But it's actually a far bigger issue than that. And the funny thing is, in a lot of places in the world, crops will fail, at least the ones that are currently growing, because of how the climate is changing.
I'm sorry, I've got an image fixated in my head now that I have to share, which is there's an episode of The Simpsons from the 90s when they visit Australia.
Yeah,
and I think the cane toads were a very popular talking point then, and to the point where they were known in America, so the writers put that references to that in.
Yeah, that's true actually.
The Simpsons were escaping. The Simpsons were escaping on a military helicopter because they'd annoyed the people of Australia so much with their behaviour,
right.
And they were laughing at the cane toads. They were looking. Oh, look, those toads are eating all their crops, and they were laughing about this. They were saying that's what happens when you introduce a species to an ecosystem that can't handle it, and they're all laughing about this. Yeah. And then hanging on to the the bars of the helicopter is a koala, and it just it just dramatically zooms in on the koala like boom. Boom, boom, as if the koala's going to go off to the US and destroy it.
You mean the drop bear?
Drop bear, yeah, exactly. So obviously more, and we've talked a lot in the first episode of this series and now in this episode about more carbon in the atmosphere is bad.
Yeah,
right?
boo.
No bueno.
I think it's important to clarify that there has been carbon in the atmosphere before. We haven't had a lot more in there than what we had in the Industrial Revolution, than what we had before the Industrial Revolution, and even what we have now. There has been more carbon dioxide in the atmosphere, but that's been from natural causes. We're talking about the carbon dioxide that we've released due to human activity, and that's the issue, because it's not natural. Like, we haven't just let the Earth evolve. We have done this, and we've done it at a rate that's unprecedented. It's
almost like I've just got an image in my head of like Exxon Valdez, like an oil spill, like when an oil tanker runs aground and just everything comes out of it at once. That's like the rate at which we've been.
Yeah, pretty much. Actually, that's a really good analogy.
Yeah.
Think of the penguins in the oil spill. That's what we're doing for the polar bears.
Another Simpsons reference is when they go to clean up an oil spill, and
when
they get there, they're like, Lisa's like, I want to clean a penguin, and then I want to clean a seal, and the Greenpeace guys are like, oh, I'm sorry, little girl, all the cute animals have already been reserved for celebrities. But we have rocks, hundreds and hundreds of rocks. So we need to stop digressing, as fun as it is, because what I want to ask is, how do we know for suresies that there is more, or how do we know that there's more carbon dioxide in the atmosphere?
So there was a guy called Guy Callender in the 1930s, I think the late 1930s, and he actually noticed temperature was going up. And he heard about, he heard about greenhouse gases. I don't even know if they had that term by then. I think that was still a later thing. But gases in the atmosphere heated the earth, right? That's what we knew. And he actually measured he plotted the temperature change and realized that it would go up and will go up more as we put more carbon dioxide in the atmosphere. But again, he also thought it was a good thing. It's like, oh, now we're going to avoid the ice ages. That's great. Like the ramifications of what this meant still hadn't settled yet. It wasn't like we're doing this at a rate that's out of control. We didn't know enough about it. But he was the first one to really measure it and calculate it by hand. Before supercomputers and all that sort of stuff, he did it by hand and using actual mathematics.
Which is really very impressive to be far ahead of the curve.
Back in the day, the first weather forecasts were done by hand, right? And they were out by a factor of, 100 or 10 or something ridiculous. But Guy didn't get this wrong. His calculations were quite accurate.
And he was an engineer who worked in steam engineering.
I did not know that fact.
Yeah, he trained as an engineer. He worked with his dad. They both worked in steam. And he was basically an amateur climatologist in his spare time.
Okay. Good on him.
Yeah, that's pretty cool.
But no one believed him, again.
No one believed him. No, he published 10... Well, it's not that no one believed him, actually. I mean, based on what I read about him, he published 10 major scientific articles and 25 shorter ones.
Mm-hmm.
And this was in 1938 that he did these measurements and calculations. And he worked out that global land temperatures had increased by 0.3 degrees Celsius in the previous 50 years.
I thought it was 0.5, but 0.3 is probably more accurate. Yeah.
And he said, that's probably because we're burning more carbon.
He knew carbon was an issue, and he had, unlike Svante, who didn't have a crystal ball, he could look back in the past and say, we've seen these increases, and then also make a prediction that if we increase it more, but it'll be fine, right? Because there'll be no ice ages anymore.
And he did this by collecting data and records from 147 weather stations.
I didn't realise it was that many, but
and then doing all the maths at home in a little book.
Yeah, good on him. Far out. Who has all this spare time?
Who has all this spare time? And he also roughly calculated how much carbon dioxide humans were putting into the atmosphere in 1938.
Yeah, that's right. He did too. I can't remember how much it was, but he estimated how much was going in.
He estimated then, and that's, just under 100 years ago now, he estimated then that it was 4.3 billion tons, and our estimates now for then put it at 4.2.
Jeez.
So close. And so you said no one believed him, and certainly Sir George Simpson, the director of the British Meteorological Society, was sceptical, saying that it's probably just a coincidence.
Yeah.
But some people did take notice.
Enter Chris Keeling. Was it Chris Keeling? It was Keeling.
Yeah, exactly. So
I always got his first name. I know Keeling, but yeah.
Well, hang on. Actually, you said that Guy wasn't too worried either, right?
No, he wasn't too worried. Not at the time.
He said that by burning carbon, we might forestall the return of the deadly glaciers.
Exactly.
And it could boost the growth of crops at high latitudes. So he was...
Look, you know what? There might be an element of truth there, right? But is that a good thing?
We'll probably have to grow crops in places like Siberia and the Arctic Circle, won't we? Because we won't be able to grow them... We won't have to grow the same crops in the same latitudes as before.
But I struggle with that concept, right? Because many millions of people in lower latitude regions will be more severely at risk.
It's not a benefit. It's going to be a consequence.
Yes, exactly.
So you've already preempted this, which is that there was backlash, there was debate, there was skepticism, but some people noticed. Yeah. And that someone or a person was
Chris Keeling.
Charles Keeling.
He was an American scientist.
Charles Keeling.
I did it again. All right. Forget that. Why do I think it was Chris Keeling?
Who's Chris Keeling?
I don't know. I just got the wrong name.
That's okay.
The Keeling curve. Every climate scientist knows about the Keeling curve. And I reckon some people have seen a diagram of it, but just not really know what it was. So Keeling, whatever his first name was, Charles Keeling.
Mr. C. Keeling.
Mr. C. Keeling. Dr. probably Professor C. Keeling took note of what Guy was saying and went on to actually measure the concentration of carbon dioxide in the atmosphere. He took note and went, if carbon dioxide was going up in the past, it's probably going up now. Let's measure it and see, and let's, then we can correlate it with global temperature as well. And that's what he did. He went to Mauna Loa in Hawaii. So the Mauna Loa Observatory in Hawaii, and he took regular measurements of carbon dioxide in the air. still taken today, and he plotted it and he noticed it was going up. Not only that it was going up, but there was a seasonal cycle, and this is in the Northern Hemisphere. So during winter, there was slightly more carbon dioxide in the atmosphere, and summer there was slightly less because plants use it in photosynthesis to make their own food. But despite that seasonal blip, it was going up and up and up, and it obviously still is today. And it's the Keeling curve that tells us where we sit in terms of carbon dioxide concentrations, and that's where I got the 427 parts per million number earlier. That's from the Keeling curve.
And he started doing it initially he did it for 5 years and used that as initially he did it for 5 years and used that as the proof that they were rising. But as you said, it's been daily readings now for almost continuously for 60 years. So it's our longest continuous record of atmospheric CO2.
Correct. And it's not just like, we don't just measure atmospheric carbon dioxide from Mauna Loa. We actually also have a site here in Australia off the coast of Tassie, Cape Grim, and we take measurements here. And it's the same thing. It goes up, like they correlate very closely. We just have less of a seasonal cycle because we have less land in the Southern Hemisphere, less trees that have their own seasonal cycle where they, make more or less food. So, yeah, it's been verified. I think there's a third site as well. I'm trying to remember.
Well, I was going to say Cape Grim, famously named for the findings.
Oh, is that where it got its name? I thought it was because it was like a shipwreck coast and everyone died there.
No, I'm being very
really? Okay.
I'm being very facetious.
You never know. Well, back then it wouldn't have been grim. I think I think even in Charles's time, in the the establishment of Cape Grim, everyone was still just curious, right? They wanted to measure this. They wanted to have the proof. They're scientists. We're skeptical until we have proof. There was still none of this like, oh, this is really bloody bad. We hadn't quite got to that stage yet. But I think there is another third official site. I just forget where it is now.
Well, I mean, maybe while we're thinking about that. So actually, there's a question. Is the Cape Grim one, when you say official site, like is it a globally important site in the way that Mauna Loa is?
So Mauna Loa would be the most important. Cape Grim would be there somewhere. It's still quite important.
I would like to also talk about a rough contemporary of Keeling. Have you ever heard of Gilbert Plass?
No.
That's okay. There's no shame in it.
I did at 9:30 last night, but I forget completely what he did.
So Gilbert Plass was a Canadian physicist who worked in the US, and like Callender, he made very good predictions about what the outcome of increased CO2 in the atmosphere would be. And he gave a talk to the American Geophysical Union in 1953, which he said some quite interesting things. I'm going to send you a quote from that talk that he gave for you to read out to our listeners.
It's coming back to me now. Yeah. At its present rate of increase, the carbon dioxide in the atmosphere will raise the Earth's average temperature 1.5 degrees Fahrenheit every 100 years. For centuries to come, if man's industrial growth continues, the Earth's climate will continue to grow warmer. Right. So, he's the first one that said human activity, the rate at which human activity will predict the rate at which temperatures rise. He got it wrong in his estimate, let's be honest.
He should have gone Celsius, not Fahrenheit.
From 1953 to now, we've warmed more than a degree. But I can understand how he got there based on 1953.
He predicted that the world would be 1 degree Celsius warmer, 1 degree Celsius warmer in 2000 compared to 1900. And in 2007, the fourth Intergovernmental Panel on Climate Change Assessment Report estimated that we had warmed 0.7 degrees Celsius in that window. So he was pretty close.
Yeah, he was a bit over, but but not bad for 1950s science, let's be honest.
Not bad at all, when no one else is worried or talking about it apart from Guy and Charles.
So less than 20 years before that, Callender was saying it was a good thing, right?
Yeah.
And
well, he's still not saying specifically that it's like, oh God, what are we going to do? But I think people are starting now to be like,
Well, that's it. And unfortunately, I don't think this was anyone's fault, but everyone's underestimated human activity, the rate at which human activity has changed. The rate at which we emit greenhouse gases has exceeded anyone's predictions thus far.
So here we are, talking about these few blokes in the 40s and 50s, 30s, 40s and 50s, starting to talk about it a bit more, and other chaps in positions of power kind of ignoring them or being not sure about it. Which leaves the question, was anyone in a position of power and authority aware of this growing problem? And the answer actually is surprisingly yes. I'm going to send you the excerpt and then I'm going to tell you where it's from.
You're not trying to get me fired?
No, I've got other ways to do that.
Good comeback. This generation has altered the composition of the atmosphere on a global scale through radioactive materials and a steady increase in carbon dioxide from the burning of fossil fuels.
So that is actually President Lyndon B. Johnson's special message to Congress in February 1965.
He had a committee, if I remember correctly.
He had a science advisory committee. In November of that year, so a few months later, they sent him a report called Restoring the Quality of Our Environment. It's really interesting to think about the fact that this was on the president's desk in, the 60s.
Pollutants have altered on a global scale the carbon dioxide content of the air. Within a few short centuries, we are returning to the air a significant part of the carbon that was slowly extracted by plants and buried in the sediments during 500 million years. Wow, that's pretty this is what, the 70s?
1965. Yeah, exactly 60.
Far out. I
don't. And the report also specifically predicted melting Antarctic ice cap, rising sea levels, ocean warming, and increasing fresh water and ocean acidity.
So let's just strip this back, right? These predictions were being made, or not predictions, statements were being made without physical climate models that we have now. So we have really state-of-the-art complex tools. They're making these statements based on scientific knowledge alone. This is not a new problem. This is something that has, we've already discussed how it's been known about for centuries. But the extent to which it could be a problem has been known for at least 60 years.
At the risk of going on a history and politics digression, I've read a bit about this over the years, and there's a kind of a theory, if not a consensus, that Johnson, Johnson inherited the presidency from Kennedy when he was assassinated and then won re-election in his own right. And he was really focused on what's called the Great Society. Like, he wanted to improve American quality of life in terms of living standards, in terms of the welfare state, such as it is or wasn't there. And he was really activated on issues around environmentalism and conservation, even if we weren't calling it that then. It was about, preserving air quality, preserving green spaces.
Before his time, really.
Yeah, he was very focused on that, and that's what he wanted to be about. But he basically got sucked into Vietnam.
Right. Okay.
Because Kennedy started putting troops on the ground,
that's right.
And then it really escalated under Johnson, and it just took over all of the agenda of that presidency.
See, another reason why America should have been caught up in that war, right? Where would we have been if Johnson could have?
If instead of being all that, because that war defines a lot of America's national psyche in the late 60s and 70s. And imagine if they'd spent that time fixing this problem. And Vietnam. So you can see from the 50s to the 60s, you can see the rapid transition from Keeling proving it with data, and everyone going, right, this is a problem.
Yeah.
And Vietnam and its aftermath and the Nixon administration's corruption gave fossil fuel companies and automobile companies the cover to start getting their denial and obfuscation strategies in place and lobbying hard while people were distracted. But we'll get onto that in another episode.
It looks like you've put Zach to sleep.
No, he's good. He's fascinating.
I've just looked up to his face.
This is the juicy bit, though. Like, we've got rid of the science. Now we're onto conspiracy and politics and war and capitalism.
Well, this is what it comes down to. I don't know, if this is the episode to unpack it or not, but it became a very political issue very quickly. And I honestly, as a climate scientist in this field, I have. Oh, okay. Sorry, I just got Zach's message. I have a deep sense of grief because this was a time where we trusted scientists. And this President, Johnson, trusted scientists and he wanted to make a change. But I was going to say it was like a sliding doors moment, but that's a severe underestimation, right? If he could have just nipped this in the bud back in the 60s, I can only imagine how much different the world would be today. I don't even think I can because it would be so different. Sure, I'd be out of a job and climate change science wouldn't be an industry. But frankly, I don't care. I would have been quite happy just studying climate or doing climate stuff, not climate change stuff.
Normal weather stuff.
Yeah, exactly. There really is a deep sense of grief there. It's so sad. It is just so sad because it would have been such an easier problem to fix. Global temperatures hadn't really gone up that much. We've had much less. I'm sorry. I'm unpacking this probably when I shouldn't, but
no, you definitely should. We want your raw emotions and distress on the air.
You want me to have a breakdown? You can probably make that happen.
It's either you or the climate. Who's going to break down first?
Yeah, well, no, that's true. I don't know. It's just, and you're right. Like with Nixon coming in, it gave the leverage for the corruption to come, and the merchants of doubt. So all the similarities with the the tobacco companies and cigarettes don't cause you cancer. And climate change isn't bad. Carbon dioxide is actually good. It's so many similarities. Like it's just far out. And I know, the thing is, I know back in the 60s and the 50s, at least here in Australia, it was all about progress. Like, let's make the world better for future generations. I remember having conversations with my dad about this, and he just couldn't wrap his head around why climate change was a problem, because they did everything they could to make the world a better place for future generations, like industry, breeding like rabbits, technology, all this sort of stuff. So how on earth could all of those decisions be bad? And I get that mental flip for that generation would have been exceptionally hard to take on. I can be empathetic there, but I wouldn't have had to have those conversations with my dad if Johnson and not just Johnson, but potentially other politicians at the time had the bandwidth to do something about it.
Mm-hmm. Yeah. So, and there's a last person I want to talk about, and you've gone in the right direction. This is about, the intersection of science and politics. And the last person I want to talk about is James Hansen.
Mm-hmm. Yes, Jim Hansen, yeah.
What do you know about Jim Hansen?
So he was a physical climate scientist and a modeler too. So we're now coming into like the 80s-ish, 90s. Jim is still alive, actually.
I was going to say this. So this is the person who now bridges. We've been talking about history. We've been talking about the people who came before, the people who are no longer with us.
Yeah.
This is someone who I think bridges the gap between the distant past and the present, contemporary climate science.
So I guess he was the father of modern climate science, or one of the fathers. There's a few of them, but yeah. So he not only modelled the climate change, so he helped build these computer models that we use so much today to understand past and future changes. And in that, he fed them more carbon dioxide and watched what happened to temperature and other global attributes. He actually went to Congress, American Congress, and said, this is a problem, and it's because of fossil fuels. It's because of our actions. And like Johnson said in his statement, we're putting things in the atmosphere that have been underground for millions and, 500 million years. Like, this is not good. We can't just simply do this and it will fall right out. The rate of change is just obviously can't find the words. And he went to Congress and got shut down in a ton of flames.
So interestingly, he started out studying physics and maths and astronomy. And
a lot of older climate scientists and even a lot of modern ones, they come from physics and maths. It's a physical problem. You need maths and physics to be able to build these climate models.
They come from abstract and then they start doing something useful.
Not me. I can just see all the dynamicists go, oh. He
was the director of NASA's Goddard Institute for Space Studies.
That's right. And the GISS model, that still exists today. Obviously not in that format, but it's been modernized again and again. It still exists today, and that's what Jim contributed to.
And he was involved in a study of surface air temperatures from 1880 to 1985.
Yep, so 100 years, it's a solid record.
And it showed that the 4 warmest years on record were all in the 1980s at that time. That time. That's those 4 warmest years would now be lovely.
So as a fellow born in the 80s person, do you struggle with that as much as I do?
What it made me think was, how is it different? Like now it's 40 years later,
exactly.
And we're saying the same thing. Oh, the 10 warmest years have all been in the last 10 years. But it's that was already happening then.
It was already happening then.
And nothing has changed except it's warmer.
So I have a graph that I show in all of my lectures and a lot of my public talks, where it's an IPCC, an Intergovernmental Panel on Climate Change report figure, where it shows each of the last decade. So each decade is warmer than the last, significantly warmer. Back in the 80s and early 90s, Jim wouldn't have had that graph to show because it would have been the first super warm decade. So I kind of I'm not sympathizing, but I can kind of understand but it was you're only showing that the last 10 years or so are really, really hot. Like there's variability cycles that might potentially account for that. So that on its own, it could be like, oh, okay, well, this is interesting, but we need more data. However, we've got hundreds of years of other scientists, multiple other scientists showing the relationship and the science behind carbon dioxide and global temperature. So to show these years in the 1980s have all been really hot, again, why didn't we sit up and take notice?
Well, it's interesting. So, you said that he testified to the Senate, actually. It was a Senate committee rather than Congress.
Oh, okay. All right. Sorry, I got that wrong. I don't quite understand American.
Congress is the House of, Representatives.
Right.
We have the same thing.
I did think he went, yeah. No, it would have been the Senate. Anyway, whatever.
Anyway, Senate hearing in 1988, and he said that he was 99% certain that the Earth was warmer than at any time in the history of instrumental measurements.
Yeah.
He said that there was a clear cause and effect relationship with the greenhouse effect and global warming. And in particular, he said that the likelihood of freak weather was steadily increasing.
Yeah, I didn't know he made that statement with freak weather. When they were talking about climate extremes and extreme events.
Although there was a lot of debate and contention and criticism, I think that based on what I've read, this was a moment when the debate shifted from science to also policy, media, public attention.
Yes. Well, because suddenly it was like, all of the progress we've made in the last few decades has been bad, actually. We did the wrong thing. We can either own up to it and change it, another big sliding doors moment, or we can bury it. So we went the bury option.
And do you know what Hansen went on to do? Like, what direction did he move in? Are you aware?
I thought he just continued doing activism.
Activism, exactly. Yeah. He did continue as a researcher, but then perhaps became more well known as an activist. And he's
climate scientists that are like that. Not a lot that do both pretty heavily, but there are a few. But he was definitely one of the first, if not the first.
He's 83 now, and he's been arrested for disrupting coal mining, and he's been arrested at protests outside the White House. In 2023, when we had a lot of extreme weather, heat waves. Oh, every year now. Heat waves and storms. He said this. I've sent you a little quote from Jim to read out.
So he said this in 2023.
Mm-hmm.
These superstorms are a taste of the storms of my grandchildren. We are headed wittingly into the new reality we knew it was coming. It means we are damned fools. We have to taste it to believe it.
Thoughts?
Oh, that's so depressing, hey? It's funny because I was speaking with another colleague of ours last night and we were talking about how we thought the black summer in Australia would be when it happened, we're like, this is really shit, right? This heat and these fires is absolutely devastating, but maybe, just maybe, this will be the event where everyone goes, oh, we've got to do more in this country. We can't just we've got to stop fart-arsing around. And then COVID happened. And it's like, and here we are again, and a few years later, admittedly at a global scale, but there's a lot of emotion there. Like they couldn't trust the experts. Like we had a taste of that in the past with Johnson, but not enough could be done. And then here we are 60 odd years later. I don't know. Like I really feel that having kids of my own and reading that, like it's true. I was born in in a decade where things were apparently warm. And few decades later, they were born. What's going to happen when they have kids? How warm is it going to be then? What storms are they going to see?
We set out to make this podcast fun. And, and when I put this script together, I was like,
cry online, but
it's interesting. I didn't study science. I studied history and politics. And so this is where what was that? Sorry?
Calling me out of my inaccurate statements.
But this is what's interesting to me is I'm always interested in human behaviors and choices and decisions. And it's so, as you said, frustrating and sad to think about having the information.
It's devastating. Like I can't, because I remember, I knew all of before we recorded these episodes, and I talked to my students a lot about Arrhenius and Foote and Tyndall and all of them. So, but it was always from a scientific, factual, like we've known about this. Anyone who says otherwise doesn't know this. But I didn't know so much about Johnson, and I knew Jim was an activist, but I didn't know he made that statement. And it's just, those things I find very emotional because things could have just been so much different. Once again, I've ended up a little bit more depressed than what I was before the episode. How are we going to turn this around? How are we going to make this fun and not Sarah has a mental breakdown?
I mean, I was going to ask you this. I said, in my naive, optimistic little script. No, I knew this would end on a sad note. I was sad when I wrote that. It's sobering and frustrating to realize how long. Yeah. To realize how long we've known as a global society what our industrial practices are doing to the world we live in. Like that's sobering. Well, not just that,
but the opportunities that we've had to try and fix it before it got where it is. I think the best way I can turn it around is it's never too late to make a change.
I just had this image in my head of like, what if you had a time machine, and it's not even like, let's say we assemble like, Avengers Endgame style, we assembled a crack team with one chance to go back in time and stop the climate crisis. It's not as simple though as going back and assassinating Hitler in 1920. Like it's not we could all go back with the same information we have now and still nothing would happen, we had the information then.
Option doesn't mean there aren't other options.
I don't know how you would fix it with a time machine, but you're right. I think in terms of what we can actually do without a time machine, it's never too late to make a change. And it's
I know a lot of people struggle with this. They're like, why don't we give up now? Like, they are genuinely depressed because of what's happened. And I can appreciate that, but it is still never too late. There's always a little bit more we can do as individuals and a lot more we can do with our politicians, but it's never too late to do more change.
It's all fine then, isn't it?
Not quite what I said, but we can make it more fine.
Thanks again for joining us on this fascinating, confronting journey.
Next time we're going to zoom in on the weather again and look at droughts and fires.
Yes, it might not be the most comfortable listen, particularly given how often we're seeing bushfires and wildfires around the world now, including in California in the winter.
But it is vital we learn more about how these extremely hot, dry conditions will show up in the decades ahead and how we get to grips with them.
Join us next time on Totally Cooked.
And we'll tackle the climate crisis together.